Hello, and welcome to the VIAVI quick tip video, how to use your DWDM OTDR in expert mode when the module is installed in your T-BERD 5800. This video will be about 5 minutes, and what we'll do is we'll show the general setup and test parameters that you'll be using, and then run a sample test and look at how to analyze results and save some data. You see, we begin on the home screen when you power up your 5800. Sometimes it might be with your BERT test, or it might be in your system tab as well. But where we want to go up at the top is where we see the fiber optics tab. And make sure that you're on the home icon down here in the bottom left to see your different OTDR applications. Here we're going to select the expert mode, which will automatically kick into not only our setup, but it'll also display the results from a previous test. It'll also kick over to this keyboard down here on the bottom left-hand side, which you can now access your file, setup, and result menus. So if we go into the setup, the setup's going to be very similar to your standard OTDRs, other than the actual wavelength that you're going to select. These are set up for your DWDM wavelengths in nanometers, but if you do prefer either the wavelengths in terahertz or via the channel, you can set them up here. I tend to prefer the channel just to make it a little bit easier. You can then set up your DWDM grid for your channel spacing, but the most important test parameter that you'll be selecting is this acquisition mode. And for today, we're going to keep it in auto mode, where the instrument will select its own test parameters for you. But you can either switch it into manual if you're a more experienced user with an OTDR, or what we call our smart acquisition feature, is in which case we'll use multiple pulse widths to get your results. And in this application with WDM, the smart acquisition feature is typically used when you have to input a large attenuator in order to balance your power on your DWDM wavelengths. And if you for example, install a 10 dB attenuator, you need to use multiple pulse widths, one short in order to get accuracy up into that attenuator, and then a longer pulse width to be able to take the loss of 10 dB and then still give you usable results afterwards. So if you're using large attenuators, it might be better to use smart acquisition, but for today we're just going to keep it in auto mode, keep the auto mode for the acquisition time. We always recommend using our OTDR connector test, which is to ensure that you have a good connection to the OTDR. And then also whether you're using a launch and or receive cable, this is where you would configure it in this menu. In order to revert back to the different menus, you just hit the top menu in the bottom right-hand corner, and then you could go through the different types of menus regarding pass-fail alarms. Whether or not you want to have them be judged. And with that judgment, whether it be a warning or a full-on fail, there are default thresholds, and then you could also have user-defined as well. And you could also save these configurations. So if you did have multiple pass-fail thresholds for different jobs, you could save configuration files, and therefore you don't have to reconfigure every single time. You could just load the file from a previous test. The analysis is how you display your results. The one thing I am going to focus on the analysis page is down here at where you see your detection. So again, in the case if you're using large attenuators, 8 dB, 10 dB, 13 dB, whatever they are, you may need to adjust your fiber end detection setting just to be greater than that attenuator. It can be tricky for an OTDR to determine whether it sees 10 dB loss as an attenuator or the actual end of the fiber. This is where you would switch it over to something greater than your attenuator to make sure that it labels it as that connector and not the actual end of the fiber. The link and the file menus are all related to your file header and your file saving. Whether you want to auto save, and if you do, what directory you want to save it to, what type of file name. But once you get everything configured, the last thing you do is just go over here where it says start and hit the start button. Like I said, it's going to automatically choose the test parameters that it's going to test with. And if you can either leave the result screen in the SmartLink mapper, which in this case you'll wait for the entire test to be done before you see the results, or you could switch it over to the trace and see an updated picture of the trace waveform as it's running through the test. Once the test is complete, you're able to toggle between either this trace screen or the SmartLink mapper screen without having to retest. Right? So you could either look at the waveform and zoom and use your cursor measurements on this screen, or if you're more of a novice user, you could just utilize the SmartLink mapper screen, in which case, once you press over on the right-hand side to the event view, you could just go through and click each one of these icons and figure out what type of event it is, what kind of loss and what kind of reflection. So in this case, we have our MUX at about 0.021 kilometers, about 20 meters. It has 4.3 dB of loss and a good reflectance at -61. We have a couple of connectors in between with good loss and good reflectance values. And then we have our DMUX here at the end. And then from here, you could either do a fast report if you want a PDF, or you could go to your file menu over here in order to save, if you want to save the SOR files. Thank you for your time.